Hi, I'm Karen Stever, and welcome to the final episode of Biostimulants, Reducing Fertilizer Use. I build this episode as the bonus of biostimulants because as we've gone through the various episodes, we've talked about nutritional efficiency being improved by some of these biostimulants. In some cases, it's nutritional uptake or nutritional transport. But any of these improvements in the nutritional pathway have the potential to allow a fertilizer reduction when using that biostimulant. So the categories of biostimulants that have this potential are the microbes, primarily the bacillus bacteria and the mycorrhizae. Humates and chitosan both, protein hydrolyzates out of episode 4, and the seaweed extracts out of episode 5. And then in this episode or segment, I'm going to talk about the new fertilizer adjuvants and the potential of micronutrients to at least get some benefit for you. All right, starting with the microbials, I want to show you some work done in the lab of Dr. Michelle Jones at Ohio State University. And what her lab did was test Pansy Growth at a continuum of fertilizer from 0 fertilizer up to 150 parts per million of fertilizer added. They tested 2 biostimulants, cease, which is our biofungicide, it's a bacillus bacterium, and the endomycorrhizae formulation. And what we see is at 0 added fertilizer, just our starter charge, our untreated plant is pretty yellow and has scarcely grown. But with the cease or the mycorrhizae, either one, we see in more growth, more leaf expansion, more greenness to that plant. As the fertilizers increased, we continue to see that our plant is still positively affected by either of these biostimulants. At 75 parts per million of nitrogen, which is half of the normal fertilizer concentration, we see that we're growing a pretty acceptable pansy there, and quite a difference still compared to the control. As we increase the fertilizer further at 75% of our normal fertilizer rate, we're still seeing the biostimulant effect, but the difference between that and the control is starting to diminish. And then, as we've pointed out before, you might not see any obvious difference if there is no stress applied to these plants or to a crop. So in this case, they're at full fertilizer, no nutritional stress, and the difference in those biostimulants is not really obvious here by just looking at the plants. Remember that our application of these products, that are biostimulant products, are through the root zone for almost all of them. So Dr. Jones' lab also contributed that the type of growing media does influence the effect of these biostimulants. As you can see here in something I would consider like a hydroponic media, sand and turf-based, compared to the peat-based mix at the bottom. So depending on your growing system, you would want to be aware of this. Switching gears to the protein hydrolyzates, this experiment was done with lettuce, and the experiment was, again, a fertilizer reduction. So their top row is 100% of fertilizer with our 2 biostimulants, unfortunately BS1 and BS2. Our second row here is 60% of the normal fertilizer with the 100% control being shown as well. The third row is a 30% fertilizer. That is with 30% of the normal rate. Again, our first plant is 100% of the normal fertilizer rate, then 30, then the 2 biostimulant additions there. And what we see and what the researchers found in all cases was that the biostimulants had kind of different effects from each other. These are two different protein hydrolysate formulations, so a different source material or a different processing, but they're both just a protein hydrolysate. And the interesting thing about these was even at 100% of the fertilizer, there was additional growth seen. So that's the opposite of what we just looked at. They found that the fresh weight of the biostimulant treated plants always increased compared to the control, and the researchers attributed this to an increase in the chlorophyll and the photosynthesis, as well as an increase in the nitrogen use efficiency. So again, a very straightforward experiment here showing what these biostimulants can potentially do for you. I want to introduce this new technology, the fertilizer adjuvant, that has been brought to us by Verano 365. They have a family of products. They're all powered by this Opus Max solvent system. And what this does is assemble the fertilizer molecules, the ions, into a supramolecular structure and somehow delivers them to the plant roots more efficiently. I don't pretend to understand the mechanism of how all this works. I will say that each of these products contains some product I would consider biostimulant, yeast extract, or humic acid, which we've seen. But the overall effect is not due to that. It is due to this organizational increase in efficiency that we get. And next we'll look at some examples of that. So EvoFactor is the fertilizer adjuvant that we would use for ornamentals or for edible crops. And I have two experiments shown on this slide, although there have been others and anecdotal reports from some of our customers who've tried these adjuvant products. All of them have shown good results that I know of. Haven't seen a negative result yet. On the left, we see finishing geraniums at 125 parts per million of nitrogen with the EvoFactor compared to the normal 200 parts per million of nitrogen. And what we see is that plant is finished earlier at 37% less fertilizer. Second experiment that I want to show was with liner production. This is doing unrooted cuttings, rooting them out, using 50% less fertilizer. Normal fertilization at 100 parts per million, reduced to 50 here. And what they found was that the plant dry weight was essentially the same at that reduced fertilizer. At 50% fertilizer savings, they were getting equal plant weight. And the morphology of the plants also look good. You can see these on the Verano website. But also important about these products is they showed that the leaching was greatly reduced. The amount of nitrogen that they tested remaining in the soil is shown here. At the higher fertilizer rate was always lower than the amount retained in the soil with the EvoFactor, even though less was applied. So that just goes to show how much fertilizer we're really running out the bottom of our pots. And it's a great environmental tool to be able to reduce that runoff. There is one last approach you might try. It's kind of, let's say, the minimal approach, and that is simply using your chelated micronutrient mixes that might already be in your cabinet. So liquid stem and most, we have rates given here. They can allow this fertilizer reduction in some crops, some cases. The micronutrient mix would be driving nutrition, but not necessarily any other biostimulatory pathways. So you might not get a full effect, and you also wouldn't get the effect of reducing the runoff more than by your fertilizer reduction, not like you would with the fertilizer adjuvant we just talked about. So if you want to try this, here are some rates suggested for various fertilizer cuts, either a 25 or a 50% cut shown here. If you use this method, we would recommend that you do soil and tissue testing to monitor the level of micronutrients, since imbalances and toxicities are possible with adding this extra micronutrient. So if you want to trial a biostimulant or a micronutrient product or the fertilizer adjuvant for reducing your fertilizer, we fully encourage that. But do trial the products and trial them within the labeled rate ranges. In addition, I would say that you need to read the labels. The fertilizer adjuvants that I mentioned, they need an incubation period. So 15 minutes after you mix your fertilizer stock tank, they'll be ready to use, but they need that time to assemble those supramolecular structures. If not given the time, you won't get the full effect of the product. However, once they're mixed up, that tank is stable. It's good for until it runs out. If you trial fertilizer reduction, trial it. The normal rates are from a 25 to a 50% reduction of your fertilizer rate. That would vary. Some people may be growing very lean to start with, and they might not be able to get that reduction, or someone growing very heavy-handedly may be able to get even greater savings. So these are all guidelines and things to be trialed in your own production. When you're trialing, make sure you do a comparison, because I think I've stressed throughout that the effects are not necessarily obvious to the without a comparison, sometimes without doing measurements, or sometimes without applying some kind of stress, like a drought stress or a fertilizer stress. So do trial side-by-side blocks. That means if you have two variables, you're changing fertilizer rate and using plus and minus a biostimulant, you really have 4 blocks to trial there, as are shown on this slide. And lastly, I'd say that I have not been able to be totally inclusive. There are a lot of products out there. I've talked about ones that we believe in the effects of, and sometimes the brands where they're a unique product. I have not intentionally promoting them, but their uniqueness deserves to be called out. So there may be other products that are safe and effective that you can also trial. So thank you for joining me on this tour of biostimulants. I hope you enjoyed each of the episodes. I feel like we've barely scratched the surface of how these things work and the details of them. If you're more interested in the science, if you have any questions, comments, or concerns, please send me an email or give me a phone call at this extension shown here. Thanks so much for joining.